so that if you have any questions, you can ask me anytime when the class is going on. Okay. Okay, let's get started. Let me tell about what is we are trying to achieve. The Big Data Chennai chapter is one of the chapter for contributing for the society to sharing the knowledge on the Big Data and Hadoop technology. This has been established in the year of 2014 to sharing the knowledge of group of IT companies people working from TCS, Cognizant, Capgemini. Many companies people are working, and then they are sharing their knowledge as a forum. This forum will every week Saturday or Sunday will conduct a class or training or to make the people to awareness on learning all the new technologies on the big data and Hadoop. Okay. So anybody joining this, you can for next schedule and all, you can click the RSVPs so that you will be get notified. So you can go through this document sessions under the file sessions to get the slides, installation guides, interview questions, and many more. Okay, those for the information I'm saying.
Join Meetup IT companies
Okay, so we get started.
Sorry to interrupt.
Yeah.
Sorry to interrupt, my friend.
Yeah.
It's Nutar. If someone is not talking right, can you please mute it? Otherwise, like we are taking disturbance.
Sure. I'll mute all. I'll mute all. For time being, I'll mute all. If any questions every 15 minutes once or 10 minutes once, I'll just unmute that, and then we can have the question sessions kind of things. Okay. So let me start the today we'll start about big data and Hadoop, and we are going to learn some of the people they are already learned this, and then maybe first half an hour maybe it could be introductions for you or refreshing course or refreshing sessions for you. Then we last time we studied about the pig and hive, so we'll learn that more on the pig and hive also today, and then there are other topics, scoop and everything we can study this week. Okay. So let me introduce myself. I'm Dr. Manikantan. I'm working for an IT company more than 15 years. I'm working for the Big Data and Hadoop more than 5 years. And then I'm into the .NET, project management, Big Data and Hadoop, banking domains, all those things. I was keen into this banking technology and then data related side many years. So I'm sharing my knowledge and experience through this Big Data Chennai chapter. Okay. So this one we are going to understand, we are going to study on end-to-end of big data. What is big data? What is Hadoop? Why people are studying this? And then what the IT companies nowadays, their most wanted technologies, big data and Hadoop. So we are going to learn on this today, understanding of the big data. What is big data concept? What are the different characteristics? How it is different from the traditional systems? What is meant by big data 3V concept? And what is big data 4V concept? What is a big data architecture, and how the data are manipulated in the big data? So that's our first 10 to 15 minutes of our sessions, going to make sure that you can able to understand. If you want to take any notes, you can take it so that you can refresh and then refresh later, so that it will be helpful for your job searching or interview questions or maybe learning the concept. Okay. So first thing, so I'm going to teach about what is big data. Okay. Big data is introduction to the big data. Big data is a collections of data set which is large and complex, that it become difficult to process using the on-hand database management tool, which means the big data concept which is evolved in the year of 2000. Okay, so before that we have the traditional database systems called MS Access, MySQL, SQL Server or Oracle. These are some of the systems are already available, which is available to store the tables, records, data into database, and then we can able to retrieve. But if that particular system, which is very complex, it is a structure-oriented database. For example, if you take the Oracle or SQL Server, you have the table structure. The rows and columns will be there. there will be field name will be there will be a data type will be there. You can insert the data, or you can delete the data, or you can do the update the data. So these are the some of the operation only you can able to do through the database management system. Okay, but over the period of internet, which is coming into the picture of 2000 and post prior to 1990 or 2000 or 2010, the data are coming in different forms: video format, audio format, image format, through social media network, blogs, internet web pages. So many things are coming. It's not a structured data, but all other internet informations and then outside information or internal organization level, some of the data are, it is unstructured, but it's a valid data for taking the decision making. Okay, how we are going to organize those data in an effective way for a business need? So that is the uh, concept of the big data. It is purely an analytical oriented subject. Big data is not the software. Big data is a kind of platform, or big data it's a kind of technology where you can able to make that data analytical side. Okay, so big data is a collections of data set. The collections of data sets so large means it can able to process terabytes of information. So that's a kind of large data. Okay, this big data platform can be used only for if you are having the data sizes minimum of 1 terabyte, then you can go for the big data side. If you are the data size is less than 1 terabyte, then you can go for the normal traditional database management system, which is fine. Okay, so but here it's a complex means it is complex means what it mean, it it cannot able to process the normal traditional database system like SQL server or Oracle. It cannot hold 100 terabytes of data. It cannot able to hold 200 terabytes of data. Okay, it can able to under for storing and retrieving for 200 terabytes data, it will be complex for that. And also it cannot able to store and retrieve very easily for structured data or unstructured data or semi-structured data into a normal traditional database system like Oracle or SQL Server or normal any other database systems in the world. Okay, that is a complex way. So the big data is providing the solutions for on the data analytical field, which is purely for making the decision making. This particular field is for analytical oriented subject. Okay, data analytical. Okay, the big data analytical, which is nowadays very popular in the IT companies, and then it is popular in the other social networks, internet, and then the other so many other field. It is very popular. Why? Because the big data last 20 years, people are developing the application development. Okay, for example, automation of hospital management software, or automation of the banking system, or automation of any other technology which is currently non-automated thing, automation of government system. So many things are automated now. People are nowadays having mobile phones, mobile applications. Those things are already developed. So each application is keep on producing the data. From this data, how we are going to manipulate using the big data technology. So that's why it is evolved in the year of 2003. Okay, so this big data analytical process examine the large amount of data in a variety of type with structure and semi-structure and unstructured. Why big data is so popular is it can able to process structured data and semi-structured data and unstructured data, any kind of data type. It can be image, it can be sound file, it can be video file, it can be text file, CSV file, document file, or structured database file, any kind of file, it can able to capable of processing that. Okay, that's why it is so popular on data analytical field. So before moving to that, we have to understand what is the, I'll come to these slides little later. Before coming to the concept, we have to understand the concept called 3V concept, big data 3V concept. So the big data 3V concept is defined by the IBM company. Okay, the IBM would define the big data, that name of big data, and then the 3V concept: data volume, data variety, and data velocity. These three concept has been defined by IBM. Okay, so what is meant by data volume? The data volume is the volume of size should be megabyte, gigabyte, terabyte, exabyte and petabyte and zettabyte and attobyte. So these are the things of volume of your data. This volume of data can be viewed in the sense of this slide. You can able to see. So normally we have terabytes of data. You might have it in your hard disk in your computer, 500 GBs of hard disk, right? So that is gigabyte. So nowadays it is coming 1 terabyte of hard disk. But if you want to store a server, okay, how much it will cost? It cost more, right? So if it cannot able to process 10 terabyte of data in one single server or one single computer. So you have to keep on add the multiple terabytes of hard disk. But in big data, they are providing a solution. No need to procure any hardware. No need to buy any new hardware. You can able to process even 100 terabytes of data in your normal home computer. So that's why this technology is more popular. So they are coming into the concept of Hadoop, which has been a distributed data system. So the distributed data system, it can able to process, you can connect to the multiple small computers, and then that can able to process your data. So before that, we'll understand the volume. What are the volume sizes are available from the big data? It can able to process terabyte. It can after the 1024 terabytes equal to 1 petabyte. After terabyte, it's a petabyte. 1024 petabyte equal to 1 exabyte. 1024 exabyte equal to 1 zettabyte. 1024 zettabyte equal to 1 attobyte. So these are the list of different volume sizes available in the world. Currently, we are in the stages of the zettabytes level of data available on the internet. Okay, so petabytes level of data, who are people are using? Banks, they are using the petabytes of data. Facebook, Twitter, so many social medias are using, so many email companies are using the petabytes of data, and terabytes of data we are normally using in our organization data. So these are the ways of data, how we are going to organize this data in the effective way. That is the concept called big data and Hadoop. Okay, so now we'll move back to the original slide. Okay, so the again we'll refresh the big data, which is collections of data set. The collections of data set means the volume of data can be terabytes or petabytes, that kind of large data set, and it is very complex to process in the normal database management system tools. Okay, that's why the big data is more popular. Okay, so before moving to the next stage, if you have any questions, you can ask me. I'll just unmute that.
Manikandan,
Yeah,
yeah, Manikandan, can you hear me?
yeah, I can.
Yeah. So you said like we can store a huge volume of data and without the requirement of multiple hard disk, right? So
Yes,
can you explain how the big data helps in keeping huge data?
definitely. I'll help you on that. Okay, I'll take this question. So any other questions anybody is having?
Hi Manikandan, I just want to ask that you said big data is not like it's an analogic, it's not
Yes,
UI or something.
yes, right.
Then how these codes are written, it's like a completely analogic set of patterns which applies, or it supports some IDE or platform.
Okay, we have the IDEs are available in the currently the market, but it is not like a traditional application development. Like okay, I want to automate a banking application. I want to do I want to create a 10 screen credit card system. I want to create a credit card system or a home loan applications. I want to build a first login screen, and then I want to create a customer screen. Then I want to store this data over there. This big data or Hadoop or is nowhere related to an application development, traditional application development. It is purely we have the IDE software, we have the other coding software like a Java and then so many other technologies we are going to use that. But this is not
Okay.
purely a development software tools, but this is purely a data analytical. We have the data of dump of data of huge volume of data. We are going to read the data, using the data we are going to do a business analytical to make use of for the business, again the business need. For example, Flipkart is the one of the company, for example I'm taking Flipkart is one of the company which is purchasing, the people are ordering the product and then they are making the order through online. Okay, so now Flipkart can able to analyze how many people are ordering from Tamil Nadu, how many people are ordering from Bangalore, how many people are ordering from the different part of region, where the people are more volume of the
Ordering
people
more
are
and liking.
more and more people are getting this product. What kind of the product the people are liking? What kind of the product we have to procure more? Where we need to focus on our next business need? How we have to grow the business? So these things cannot be able to do it in a normal weekly report. Even the normal application that will provide the invoice report, it will provide the sales report. The sales report will be tell about the what is my previous sales is happened. It cannot able to tell me what is my next month. I need to be should be prepared. What much of the investment I need to do for a next business growth. So those kind of things, it
Okay.
is a purely analytical oriented. So similar kind of things. If you take the healthcare, so healthcare, what kind of the disease is going to come? So it can be they might have the large size of data source of information from the across the countries. Based on that, they have to do analytical. For example, weather monitoring system. We have to understand how much of the weather it's going to change, whether the tsunami is going to come or not. So we have to do so much of analytical work based on the satellite information or based on the other sensor information. So these informations are every second there are volume of sensors are producing volumes in a megabytes of level. Okay, so these data need to be analyzed. So that analytical things can be used for the any kind of purpose, and this big data and Hadoop can be used for any kind of field, any kind of domain, and whatever the ways we can do the analytical, we can modify as it is. Okay, and I'll move
Sure,
back to
sir. I
the
understand.
next question. I'll move back to the next question. I specified there is no need of procuring any new hardware or software or maybe anything is not required. It's a normal home PC itself enough. So I'll go back to that question. Okay. So if you're considering your normal client server technology, the client server technology means you're having the SQL server and then you're having the .NET application or Java application or Oracle, whatever you're having in the server. And then the client, if you're working in an organization of any company, you can see that, okay, you have to connect the server, then get the data to your application and load it and again save the file into the server. Similar way only we are working. Okay, 1 second. The slides are gone. Okay, so there is a client server technology, sir, we are currently using on the organization, right? So when we are using the client server, if you are, have you ever think through that how much of the server, how many server we are having in the organization? What is the data volume size of that particular server? So how much of volume of data we can able to store? Why the server is costly and normal computer is very less? Have you ever thought that? So why this our normal computer also in our organization in our desk also we are having the same kind of i5 processor, 1 TB of hard disk, and then same kind of RAM or those kind of things, right? So, but in the server, if you're adding the fault tolerance because it need to run 24/7, so that's why it is little costly. The hardware components are little more powerful of RAMs, the speed of server, of architecture of motherboard, little changed. So that's why it is little costly. But if you are storing a data of per GB, okay, 1 GB of data, it is costly. Okay, if you are storing data in the server and then if you are storing the 1 GB of data in your normal hard disk, It is costly. Okay, so if you want to process 100 terabytes of data, the ITL infrastructure, what they will do, they will have a data center. For any company, if you are working for any company, if you are having multiple server, large server systems server, they will maintain in a data center or data server. It is called ITL process. They'll maintain in a big server. If you check in the big server companies or some kind of software companies, one second, I'll show you the how the data centers will be look like. Are you able to see my screen? Hello? Okay. Okay, if you are seeing these are the server racks. Okay, these are the computer where you can able to store and retrieve your data of different servers you can able to maintain in a server. It is in the cooling computers. Okay, these are people are maintaining like a Google or Oracle or many companies, they are maintaining the data center. So these are the data center. Okay, for each server will have the multiple hard disk. Okay, each data servers will have multiple hard disk. Okay, so what will happen for storing and retrieving this will be more costly instead of normal traditional system. This technology has been changed to a distributed data based distributed system. This is totally changed the concept. Instead of client server technology, we stopped the client server technology. Instead of client server technology, it was completely changed to master and slave. Instead of server is processing the data, we are storing the data in the server, it is going to process in the client machine. It's going to store in the client PC itself. The server will just run as a commander. Okay, the commodity hardware means it is the normal PC. Commodity means commercial hardware. The commercial hardware which is available in the market, which is itself enough for the home PC. The home PCs are called commodity hardware. So the commodity mark means you can get it in the local market itself. Okay, so if you can go and buy the i3 PC in your local market, you can go and buy the i5 systems. This technology, how it's working is, if we are connecting one computer, you'll get a one computer of processing speed. If you're connecting 5 computer, you are going to connect 5 different computer of power. You have a laptop, you have your home PC, you can connect through some LAN cable and you can able to process of 10 terabyte of data also. It is not going to store 10 terabyte of data. If you are having the 500 GBs of hard disk in your one PC and another 500 GBs of hard disk in your another PC, it is not going to make you do storage stuff. It is going to take up packets of data. Okay, based on that it's going to make use of that. Okay, once again, many people are trying to contact me. People are unable to join because it is limited to 25 people only. Okay, so I'll tell you the concept, client data concept. The client server technology, you might be aware. There is a server. Even if you're requesting for one web page, the website, if you're requesting, then the client is sending a request and server will respond back to the client. But in the big data or Hadoop, the technology has been totally changed. It is going to make it a server into client, master slave concept. Instead of client server concept, it is called a master slave concept. All the PCs or computers or laptops called slave PCs, and it has been connected to one single master PC. That master PC also can be a commodity application, or it can be an upgraded of little bit costly of systems. That is the only recommendation it is providing, but it will not act as a server. Okay, it will act as a master and all other systems are slave PC, all kind of concept. It is a distributed data processing. Instead of one computer processing, for example, if you're 100 clients, they are requesting, 100 people are requesting for web page. What it will do, 100 client request will be get processed in the server, and server will respond back to the 100 clients, right? But here, what it will do, the server master will send a request to the 100 clients. The 100 client will process the data. Based on the processing data, it will respond back to the server. Okay, this is the result for you. Okay, then the server will make the final answer. So that's why it will work. Okay, any questions on this?
Yes, Manikanda, it's no turn. In order to achieve this one, right, we need, even you're telling is commodity hardware, but if I have a very less RAM, will it work for that to process all this kind of big data?
Yes, even if you have the 2 GB RAM, it will work. That's not at all a problem. It is just a
Oh.
basic Pentium PC also is enough for to make it use of these systems. And also, it is, yeah, please raise the question.
Yeah, another question. So when you said slave PCs here, are we talking about setting up these slave PCs as part of big data, or while the client is requesting, you make the client machine as a slave? I mean, are you going to procure all these client machines in your LAN setup, and then as part of serving hundreds of requests, you are going to make it work as master slave, or you will have only the server PC with you, and then if people are requesting, you make their client PC as a slave?
No, it's not like that. So here, you can make any kind of computer to as a slave or server, anything. You have to just have the IP address of the particular system or a particular PC. This software automatically will work as the slave. You have to just specify these 3 computers are slave PC, and this one system is called master PC. That you have to settings. The settings will be, the installation settings will be there when you are installing the Hadoop software. There you have to specify, consider the configuration file. This IP address are slave PC, and this IP address as the master PC. Then based on the configuration, the software will automatically work according to the configuration. We no need to have a separate client. When client is requesting, it will not set. It is by default. You have to install the Hadoop software in all the PCs, all the client PCs. You should have one system should have the configuration of the master, and all other systems should have the multi-node cluster. That's called a multi-node cluster. But I don't have a 100 PC or 10 PC or 1 PC. I don't have a 5 PCs to connect. No need of problem. If you have only one PC also, you can able to process of 10 terabytes of data. That is the beauty of the Hadoop. Okay, how we are going to achieve this is, we are going to do a process of one PC if you are configuring as a master, and the same PC can mark it as a slave PC. Like in same computer you are having a server, the same computer which act as a client. Similar way here it will act as the master, the same computer will act as the uh, client or slave. That which means it is called single node cluster. This concept is called single node cluster. The commodity application means the normal home PC of i3 or i4, i5, the normal Pentium 4 systems, which is normal computer, is called slave PCs. Instead of the job is doing by the hundreds of requests is processed by the one person, one server, the one request will be get processed by the hundreds of PC. That is the concept called master slave. For example, in a classroom, consider in a classroom, a teacher is giving a conducting an exam. So 100 students, they are studying in the class, and then they are collecting the paper, and one student, one staff or one teacher is correcting the paper. Okay, for correcting the one paper, it will take 1 minute of time. If for 100 paper correction, it will take 100 minutes of time. Okay, instead of that, teacher is giving the paper to the all the other randomly giving to the other student to correct the paper. Okay, so each students will take one minute of time. So within 2 minutes or 1 minute of time, all the papers are get corrected, that means your task is completed. So that is the concept called master and slave concept. So it can able to process. If you are connecting 10 PC, you will get the power of 10 PC power. If you're connecting 100 PC, you'll get the power of the 100 PC power. But if you're connecting more and more PC, the maybe the milliseconds or the minutes may be reduced. But even if you connect 1 or 2 PC itself, you can able to process of terabytes of data at a very less time. Clear on this?
Manikandan, I have a question.
Yeah.
So if I have a PC with more levels of hyper-threading, because to process a request, the number of hyper-threads in my processor is what, how you do a processing, right? So if you are talking about the slaves, number of slaves and then processing request, instead of that, if I have a machine with a very good processing configuration, if I have a multiple hyper-threading, able to process 20 threads or 50 threads, I can achieve the same in single machine itself, right? So how does it make a difference by distributed way?
Okay, perfect question. So here, the hyper-threading concept or threading concept will be working in a same process only. For example, in single PC, you're working hyper-threading on the same process you're hyper-threading. Okay, but here multiple PCs. Okay, the data will be going to distribute in the multiple PCs. For example, the computer 1, computer 2 and computer 3. You are connecting 3 different computer, which is the hard disk capacities of 500 GBs of hard disk. When you are connecting, when you are having a 200 GBs of data of 200 GBs of data for data processing or 1 terabyte of data for data processing for a calculation. Okay, what it will do, the same computer, the computer of big data or Hadoop software will decide which computer need to be, algorithm will decide which computer I need to process, which computer is currently working on, and then based on the capacity and then based on the process, what is the current process happening, based on that it will decide whether it will split into multiple piece of data. Okay, so by default in big data it will split into, each block size is 64 MBs of block. Consider this is a hard disk. Okay, in a hard disk you will find as sectors. Okay, I'll just put into one slide hard disk. Okay, so we have to understand how data are writing in the hard disk. Okay, so the hard disk will be get right into the multiple data blocks, zeros and ones of data blocks. When it is writing multiple data blocks, in the current hard disk system will be right in the zeros and ones of 3 KBs of data block size. Okay, each block will have three multiple blocks, and then if you are writing 1 MBs of data, there are hundreds of thousands of data blocks will be there. That data blocks again it will be going to read as a one file. Okay, so when it is going to read, but if you want to process 1 terabyte of data, is it advisable to process into 633 KB or more data block size? So it is advisable to do more data block size. That's why we are having the new technology called Hadoop software, which will provide you the logical layer on top of the logical layer. It's called Hadoop distributed layer, Hadoop HDFS layer. Okay, so we'll deeply study about that. So before that, we'll just go through this slide and then we'll understand how the big data is started. Okay, how the big data is started, where and all these big data are using, how the big data is more specifically there people are using all these things. We'll start study about that. So we have to clearly understand the concept called big data 3V concept. The 3V concept is data volume, data variety, and data velocity. So in the data volume in terms of, we already saw about the what is megabytes, terabytes, gigabytes, petabytes, attobyte, and then attobyte kind of things. There are multiple volumes of data volume we started. The big data can able to process any kind of data size. It can able to process even the MB file, KB file, terabytes, gigabytes, but it is advisable to make use of the big data if you're having the large volume of data. You have the terabytes of data, gigabytes of data, more than exabyte of data, petabytes of data. You can go for choose for the big data technology for your data analytical. If you're having 100 MB file, Instead of 100 MB file, you no need to go for the big data, all other stuff. You can go for the normal traditional database system, or so many other BI logical tools are available. You can make use of that for your data analyticals. Okay, and data variety. The data variety in terms of, you can able to get process the big data variety in terms of multiple varieties of data. It can be text file, or can be CSV file, or photo file, video file. For example, in your normal traditional application of database system like SQL Server or Oracle or MS SQL something, you cannot able to process video file, thousands of video file in a quicker manner, but you can store and retrieve, but you cannot able to process in an effective way. It is very complex to process. But in big data, you can able to process structured data. Structured data means tables, rows and columns. Those are structured data. Unstructured data, it can be any document file, text file, video file. Those are unstructured data. And semi-structured file, it's called XML file. Okay, any kind of data file format, any kind of data varieties can able to process through big data technology. So that's called data variety. That's the second concept of second V. And third V is the velocity. Velocity in terms of speed. How much of fast I'm going to able to process. In the normal traditional system, you can able to process in the batch mode or interval mode or real-time mode. These are three modes are we can able to process. But in big data mode, it's called sparse mode. The data velocity, it can able to make the data operation very fast. Okay, because of the distributed database concept, we can able to process the data in a very fast way. Okay, how it is going to achieve means, you can able to process 1 terabyte of data also within a minute. You can able to process your 1 terabyte of data also. So that's a new architecture has been defined by the big data platform. That architecture called Hadoop. You can process hundreds of terabytes also in a quicker way. How it has been achievable, we are going to learn through that. Okay, so before that, do you have any questions on this 3V concept? It's a very important concept of, if you want to understand the big data. It's called data volume, data variety, and data velocity. Do you have any questions on that? Yeah.
Yeah, can you explain how do we analyze the video files or some kind of files, how does big data help to process these kinds of, unstructured or, whatever the video file or in terms of photo, how do you process it actually using big data?
Okay, so in big data, if you consider there's a YouTube channels, or you can consider the Facebook, or consider the internet, there are many websites which is having the multiple pictures, videos, files, and everything. Okay, consider there is news about a currency note conversion of the in India. So you want to understand the sentiment analytical of what is happening on the countryside, across the country, what is happening for making some decision. Okay, if some elections are happening for across US elections are happening, so you want to see what is my sentiment analytical, who will going to win this particular thing. So how many people are debating on this internet, videos files or audio files, or maybe twitters of text files. These are the unstructured data. So if I want to get process this data, so the Hadoop, which is having the data type, which can able to read and write the multiple video file formats also, that the raw data can be that can be any kind of data. Okay, it is going to process the zeros and ones, that is going to read as a raw data. That raw data will be get converted into multiple data chunk of blocks. That block, which is whatever the logic you want. Okay, you have to define your logic of business need using this data. What you have to do? Okay, you have the 1 terabyte of data of audio file. Okay, you want to see whether this audio file is containing this particular audio, or this particular section, or this particular speech is there or not. That is your original goal. Then you have to have what is the content you want to do. Then it will be automatically compare all the videos which is available, which is matching only. It will go into process to the next level. For example, in a normal RDBMS, you are going to search you have 1 lakh record. Consider one particular table which is having 1 lakh record. If you are writing a query, select star from employee table where employee ID equal to 17,000. Okay, what it will do, it will go and search the first, it will take the first record, whether this record is matching to the query. No, it is not matching. Then it will leave. Then it will take for the second record. Then it will check for the whether it is matching. Similar way, it will go for the multiple record, 17,000 or 20,000 record. Then it will go for the 17,000. Okay, 17,000 record. After processing, it is found that result 17,000 record. That's one record is found. There is employee ID is found. So it is going to show to the result to you. But in big data concept, since it's a distributed environment, it is not going to process you all the records. Okay, first it will take the first block of record, whether it is matching to your condition or not. Then it will move forward to the next level. Okay, it is do the sorting, shuffling. That's we are going to study how the data processing is going to happen in the big data. That I'll come to the few other slides later. I'll explain you. For video file format or audio file format, we have the raw data structure type is available in the Bigdata-Hadoop technology. So there is a data type to read video files and audio files or unstructured data types. That is going to convert into a different format. That format is going to work in the big data. Okay. Any other question on the 3V concept? Shall we move on to the next slide? Okay, I got another question also. Cloud is a platform which we can able to deploy either client server architecture or master slave architecture as a cluster system. Yes, nowadays cloud platforms are available. Instead of if you don't have the system, if you don't want to invest another PC as a cost of 20,000 or 40,000 rupees, you don't need to invest. You can go for the cloud platform. These cloud platforms are available as the master and slave architecture. Okay, this cluster servers or master slave concept. It's not a client server architecture. Even though if it is a client server model, if you install the Hadoop platform software, that will convert the clusters as the master and slave clusters. Okay, we'll read about that more. And then other question is from Jay Prakash, how master slave architecture is different from the cloud computing. Okay, the cloud computing is you no need to invest any hardware part from your packet. There are many providers are available in the market. They have invested and they are having the data center. They are selling for based on your usage. You can use it for 1 hour or 1 month or 1 week or 1 day. Based on that, you can pay for that pay per usage kind of concept. That is called cloud computing concept. Then if you are having your own systems, you can convert those as a master and slave PCs. And then I have questions from the Ajit Kumar. Traditional systems are centralized and then big data is based on the distributed architecture. Yes. So traditional systems are in the normal. So we'll go to that slide so that we'll understand more on the how the traditional systems and then the big data are changed. Okay. The traditional database system, the traditional systems, what we normally do, consider the big data approach, how the big data approach on the traditional analytical and then big data analytical. Before big data also or after big data also, the traditional analytical still available. You can able to process using the BI technologies of tools. Still there are lot many business intelligence tools are available for your data process. So normally in a traditional approach, what you'll do in the software company, you will have your own customer. The customer will have the new requirement. That requirement will become as a business requirement document. That business requirement document will create an architecture and then you will start designing the database, screen design, and then you create a STLC process, design, develop, coding, and then testing, build, and deploy. Then it will go for some new requirement. That is your normal traditional system. But in the big data approach, it is not the systems, the requirement will not come from the business. You can able to create your own business. You can able to create your own platforms. You can able to create your own business methodology using the big data approach. How? So the traditional approach system, the business user will come into your IT company and then they will approach to build a application. But in big data approach, you can create a any kind of data platform, and then you can create your own business logic. That business logic will create a new business approach or new business insight for building through business big data approach. Okay, for example, you can create a product strategy analytical, which product is going to familiar for customer sentiment. For you can sell it for Flipkart, you can sell it for Snapdeal, you can sell it for any other platform which is available in the market. So that logic you have to create using the big data approach. You can create a new business opportunity through big data application or software development activities on the big data analytical side. So where and all these data are available? So these data are available from our existing traditional source of data. The existing traditional source of data means the existing servers. We might have processed last 20 years of data which might be available. Those data also we can use. And then data warehouse and business platforms like a Twitter, Facebook, internet, media, social media, all these things we can able to get. And there are so many data warehouses are available from that you can take. And then there are new data sources, if anything, you can able to get it for data analytical. So these are the ways you can able to process. How it is different from the traditional platform and then big data platform. So traditional platforms which is able to process to gigabyte to terabyte level, but big data platforms can able to process to petabyte to exabyte of data. It is the traditional system is centralized data structure, but the big data is the distributed data structure. The traditional platform you can able to process only the structured data, and then the semi-structured data you can able to process, and unstructured data also you can process in the big data platform. The traditional system is the relational database model, as RDBMS concept, but in big data it's called flat schema model. And traditional platform is batch oriented loading process. It batch by batch the data will get processed, but in the big data it is a real-time data article. Okay, so here traditional approach will be, yeah, please go ahead.
Yeah, the flat schemas you're talking about here, right? So
yeah.
if you take a NoSQL database, the data is stored as a document in form of JSON structure.
Yep.
So how different it is from the flat schemas?
Okay, so it is a difference is there. For here the flat schema, how they are referring is the basically in a Hadoop HDFS layer, there is a raw data sir gets stored as a block. Each and everything is make it as a 64 MB sub block. That's why it is called flat schema. There is no relation between the one data to the another data, but the business logic only get related to that. But here in the relation database management, you have the one-to-one relation, one-to-many relationship, all those things are available. Here that all the data are considered as a raw platform of flat schema data.
Okay.
Okay, so in the normal traditional system, we are processing through batch oriented, but here it's coming the real-time analytical. So in the traditional system, you are going to process, even the traditional system also, there are BI technologies are available, business intelligence, that you can see through the analytical through the historical data. For example, last 6 months, what is my sales report? Last 2 months, which product is selling more? If I'm having a grocery store, which product is selling in this particular market? So those things I can able to, still I can able to do an analytical work on the traditional platform, but that will not give me a sentiment analytical. What is my future business? What is my future analytical? Where my business are going? How I'm going to become in the next 1 year or 2 years? The business decision making purpose, the big data are more useful for many domains, many platforms. It is be useful. And then the traditional data platform, which is the data entry based system, like a data entry means there is a UI screen will be there you have to feed the data of customer data or sales data, all those things. But here the big data analytical, the data coming from the various data sources like a RFID, sensors, weather monitoring sensors, satellite informations, internet world, social market, mobile phone, other networks. So many things it is coming from the data are coming from the different platforms. Okay, some of the technology where big data are using here is the web, e-commerce, internet. People are using for integrating the website analytical, and then the retail market. You can see where is the competitive price. So if you can able to check the same product, what are the various different prices, competitive pricings, customer segmentations. Who are the people are looking forward me iPhone or some of the products which they are planning to launch. For example, iPhone 7, if they are going to about to launch, so many people might be tweeting on the Twitter, or so many people they are talking about in the Facebook. Okay, if you are having the Facebook data, you can able to take the Facebook data, since it is a public data. You can do a business logic over there, and then you can do a Hadoop software install, get the Facebook data, and then read through that, sequence that, make it through process of times master slave concept, and see the writing the business logic queries should be who are all people are talking about the iPhone 7. So that could be your target audience. So now you are doing the data analytical for, you find your database of the list of customer who are the my target audience, so that I can reach the approach those people, I can increase my sales. So that's called customer sentiment. Predictive bias behavior, who are the people are, how the people are talking about my product in the market. So predictive buying behavior, market campaigning management. So these are things, a retail market, the business data, big data can be used. And government thinks there will be a defense intelligence analytical, threat analyticals, so many other platforms we can use. And telecommunication, customer experience analytical things we can use. And healthcare and pharmaceutical, drug discovery. If you want to perform a new drug, we can do a big data, there are large data we can able to analyze instead of many other data source, using data source. And insurance, customer segmentation, service responder segmentation, and financial fraud detection, analytical, credit card fraud, money transaction, those many, so many things we can do through the data analytical in the financial service. And manufacturing, inventory optimizations we can do in the manufacturing. And then you can do the energy and utility, media content. So many other fields people are using the big data. Okay, so now we have to understand more onto the who are the people, who are the vendors, what is the big data, all those things we'll understand in a big picture. Here, the hardware and softwares which is being provided by different vendors. Okay, consider the hardware part is normal, our normal hardware. If you can buy the Intel computer or Dell or IBM or Cisco or whatever the systems you can buy, that's hardware procurement side, server or storage. But even if you're purchasing a commodity hardware, you can go and purchase the Dell PC or Dell laptop or IBM laptop, Lenovo laptop, both those things. So those are things are hardware side. But in the software side, who are the people are providing the software? Okay, the big data is a purely an open source software. Okay, it is not like a one particular company they are providing software. There is a company, there is a technology provider who developed this particular technology. Then they made it in a open source. So before going to this software, Hadoop distributed database software, we have to understand the big data history. Okay, I'm going to walk through the big data history, why, how the big data is come into picture, that we'll see. Then we'll come back to this particular slide. Okay. Okay. So let me introduce the person name called Doc Cutting. Okay. Doc Cutting is one of the person who found this Apache Hadoop. Okay, so he written this software using Java platform. He is basically lawyer. He is interested into computer, and then based on that he started writing the software code. Before he comes into the picture of this Hadoop, there is a business logic is required, right? So why they are starting this Hadoop? Why he written a big data means? I'll tell you that.
So, Manikandan, like Hadoop is just a Java-based framework for implementing the big data analytics, right? So, likewise, for other technologies, for .NET, and then for other languages too, do we have any frameworks, or how is it actually?
Yes, it is for, it can able to accept many other language. It is not required only for Java. You can able to process many other language it supports. Even it supports C, C++, so many other languages are support. It has its own language also. Hadoop is having it as its own language. Big Hive, so many other tools are available. I'll go through that. I'll come to that picture in the another 5 minutes later. Before that, I'll introduce history of big data. Okay, for example, Google the company. If you go to the Google search, okay, Google is started in the year of 1995. During that time, 1998 time, when they want to growing, they are growing in the worldwide. Many people are keep on searching the data in the Google. Okay, many people are searching the Google. Have you ever tried the Google search and then Yahoo search? Yahoo also one of the company, right? Yahoo.com. I'm just putting. Okay, are you able to see my screen? I have the Google as well as Yahoo searching. Are you able to see my screen?
Yes.
Okay. Consider you want to search about some data as a big data. Okay, big data job. Okay, I'll type some other stuff. Okay, what is I'm putting the same content in the Yahoo and then in the Google. What is happening in India? Okay, are you able to see? I'm just typed in the Yahoo search what is happening in India. Okay, so I'm getting the list of result as Times of India as the first URL and news, and then first part, these are the things are in the India. But in my Google search, same thing I typed, what I got is, I got instead of Times of India, I'm getting Quora.com, India Times, Maps of India, India Today, all these things are coming. So the text is same, I'm not changed anything, but I'm using two different search engine. It is giving me two different answers. Okay, why? Anybody is aware of this? Why it is coming two different answer? This is also connected to internet. It is also connected to internet. It is also connected searching through all the World Wide Web. Here also they are searching through World Wide Web. How it is different?
Because the search algorithm would be different between these two search engines.
Okay.
And the priority of fetching the data might be different here.
Okay. Okay. That's okay. That could be one answer. Mike, okay, I'll tell you even more better. What is happening in India, if I search and click, I can see there is about 6 millions of 3,000 of 00 result in 0.82 seconds. And here I can able to see there are lots of informations. I can able to see 168 crores of results which is available in my search engine. How this record can be able to within 0.82 second can able to given me a results of across the World Wide Web. It is connected to internet and then globally it is going and searching what is happening in India and producing me 6 crores of results in 0.82 second. So if you're having a normal database system of your SQL server, in your normal experience, you might be facing, if you're having one GBs of data or 1 lakh of record of data, you search in your SQL server or your home or your office, you might be faced to get a result of 1 lakh record of data you searching and showing the result. It might take you at least a minute of time to show the report or something. But the Google or Yahoo or some search engine which is producing 6 crores of data in a 0.82 seconds. How it has been possible? So that will give you the answer for the big data, how it has been come into the picture. So anybody have any answer for that?
So it might be the distributed processing.
Okay, one answer.
They might meaning deployed grid computing.
No?
No, they indexed all the data. When you
Okay.
search, it will get the data immediately.
That could be one possible answer. Okay. So if I'm typing what is happening in India, are they going now on 10, 11, 4 p.m. and then they are searching, the system is going searching and producing me 6 crores of result, or it has been searched many days before, or how they are maintaining this? They are having algorithm, fine. They are having like how we have our application code, like a software code, as the our how we are writing for application for searching the data. They are also having same kind of logic. They are going to connect with the server, get the data. So how they are maintaining is each 24/7 this algorithm, how the keywords, whatever we are typing, what is happening in India, similar kind of keyword, there is a database or there is a combination of letters, combination of worldwide search people are typing, that will be keep on search and store the data of this URL and result pages into their server. So like a Google company, Yahoo company, they'll maintain a big server on data centers, Google. Okay. So each and every millisecond, these data are captured and stored in the multiple computers. Okay, these data are searching through. It will not going to search you the minute when you're typing. It will not going to search. It has been searched maybe yesterday, maybe today. Anything might be possible based on the algorithm when it has been get processed based on their database of SQL Server or Oracle, how they are storing and retrieving. Based on that, they are getting the result of these many records from their database. Okay.
So, Manikandan, if they browse, let's say if I'm going to type this word for the very first time, somebody is going to type right.
Okay.
For the very first time, how does it, because you're trying to say that, as and when people types it in browser, it stores this kind of a search text in kind of a cache or in some server and the respective results. So that if somebody else is going to type the same text in a browser, it will search, okay, initially whether this has been searched by some other user, then if I have the results, then I quickly retrieve it. So for the very first time, how fast it is going to be?
Okay. The very first time also what it will do, there is a combination of keyword. The algorithm will keep on search the multiple combination of keywords, then it will keep on store the data into the database. Okay, if the text is not even available in the, for example, I'm typing some unwanted text over here and then I'm just putting, okay, so here this particular search of did not match of any document, but it is not even gone through my whole internet, right? Could you able to see some, I just typed some nonsense text over there and then I put this search, did not match to any document. That document means their server. Okay, it may be available in my home PC, this text, or it may be available in my Facebook comment or comment section, or it might be available in my Twitter comments, something. Okay, but it is not available in the Google search. That does not mean by that this text is not available in the world. Okay, the Google search, how it's working, it has been working in the combination of text which is available in the world. So based on that, India, it might be have multiple search. They might have a filter. Okay, based on India, if you type only in India, okay, if you type only in India, it has different 2 crores of 2.747 274 lakhs or 274 crores of data which is available, which is previous search. From there, I'm putting what's happening in India. They might have a filter query. They might do a filter, sorting, all those things. Then it will produce for 6 lakh, 6 crore data. Similar way it will work. Okay, but every content of URL, the things happening over there on these stuffs will be 24/7. This algorithm will keep on searching the internet and then it will store into their servers. From the servers, it will be come into picture. So our question is totally different. For example, when Google started in 1995 and then they are facing a problem, so many lakhs and lakhs of people are keep on sending a request to the server and then they are getting back to their response. Okay, that's a client server concept. Clear on this? How Google search engine working? If I want to search anything, I'll go to the google.com, then I'll type the text, then I'll get my response. Is it the way only everyone is doing, right? So when people are growing, when internet world is growing on 95 to 98, Google is unable to store and retrieve very faster way. Okay, for example, now it is coming in the 0.52 second or 0.50 second. Okay, previously it took me 0.52 seconds. Okay, this 0.52 second, it need to search 5 crores of records and then it need to produce my result, right? So they are unable to store and retrieve the so much of large data of 5 lakhs of these URLs, the content, what are the different keywords, such things, everything they have to keep stored in their database, then only they can able to search the content. Okay. So when they are unable to store and retrieve the large data, for example, if you are storing your resume, that it will come 500 KB, right? Okay, but if they want to dump the entire World Wide Web and then based on the keyword search and then based on the URLs, what is available, the link of that, those things they have to keep stored into their database and then they have to come back over here. You're getting the point? So when they want to store and retrieve, they are facing a problem. They could not able to store and retrieve the large data in an effective way. Why? Because of the hard disk. Where they are storing, they are also storing the server, right? In server, how it's getting stored? It is storing in the hard disk only. There is nothing, no other place to store, right? The hard disk, they are getting storing and retrieving in the blocks. Each blocks would be 3 KB. That's called a sector. The sector, it is going and storing the data, and then based on that, it is coming back to you. Okay, there are freeze sector, there is a return sector. Those data are available, right? You're clear on this hard disk sector, right? This is how the data are getting stored and retrieved.
Yes.
Okay. So here, storing a sector of on a particular track, and then when it's retrieving, it will take a time. For example, if you have 1 MB of data, 1 MB of data, which is very easy to retrieve. So because of your Microsoft OS like Windows or Linux or any other operating systems will go and fetch your data in the hard disk. Okay, so their intermediates are there. That's why you can able to get your data. But if you want to store a 10 terabyte of data, 10 terabyte of data, and then you want to store and retrieve, that means the 5 lakhs records of data which is available in the internet. For example, here 5 lakhs 26,000 results in 0.5 second. Okay, this data they cannot able to store and retrieve in the 3 KBs of data. It will take very long time. The search result may be 10 minutes or 5 minutes or 2 minutes previously, maybe in 20 years back. It's taking time. It's taking long time to store and retrieve. They are unable to organize this, the entire dump of data in the internet world. So they want a solution for this. That's why the big data are evolved. Okay, so they want to store. They want to have a result. How to store a large data? Okay, instead of 1 terabyte of data, 10 terabyte data, how to store a data? So they found a Google file system. Google file system. Okay, Google file system, which they have been they try to find a solution for that. Okay, the Google file system, it is a research document that has been found by the Google company. Initially they're facing the problem. So one of our Indian scientists called Sanjay, and then then there is a other two other people, but the two people is the major contributor, Howard and then Sanjay. These people, they written a white paper. They found they are also they are employee of Google. They found things instead of storing in the hard disk 3 KBs of block size, we have to store and retrieve as the 64 MBs of block size. So I'm just searching here 64 Once again. Okay, so previously we saw about the hard disk sector. What they are recommended is you have to store and retrieve the Google file system. You have to store and retrieve the files as the 64 MBs of block. So we cannot able to change all the hardware which was built already, right? They created a software layer, software logical layer. Any data which is coming to Google file system, when it's storing and retrieve, that will be combination of multiple blocks. That one block size is 64 MB block. So that is the Google file system. This Google file system has been built on the year of 2003. Okay, that's the first version which has been recommended, the year of 2003. The particular Google file system has been defined. Okay, so clear on this?
Where do they store this 64 MB of data? Because hardware sector stores only 3 KB. So somehow if they are creating a logical layer on top of it, they must be storing this, right? So where do they store?
They are creating a logical layer on top of our hard disk. They are storing and retrieving the 64 MBs of block. Okay, so this Google file system, they are facing this problem, right? How they are unable to store 10 lakh record, 100 crores record into their hard disk. Storing and retrieving it is taking time, so we have to find a solution. For that, they found this technology called Google file system. Clear on this?
Yes.
Okay. After Google file system has been published in the as a research paper, so Sanjay, who is the person, this guy, the photo which I'm showing, right? He just worked in the Google in the late 99, in the distributed platform. So he started working on this other technology of data management. So he recommended, or he just found the solution for how to store and retrieve the large data. So that's why he proposed the Google file system. So during 2003, okay, we are storing and retrieving the files, but how to process very faster? That's another problem. Okay, I'm storing in a logic layer 64 MB. I want to process, even if I store the 100 terabyte in my hard disk, I'm unable to process it if you are copying from your one hard disk to another hard disk, you have 500 GBs of hard disk. You want to copy your 500 GBs of hard disk from one hard disk to your friend is coming to home, and then you say, hey, can you copy 10 movie which is available in my hard disk? Can you copy that movie so that I'll watch it in my home? So what you'll do, you're just